So let's talk again about nodal analysis and how to write nodal equations. Now we'll be writing nodal equations for this circuit with three nodes, V1, V2 and V3. Looking at the diagram, it looks a bit scary, a bit complicated, but it's actually not that bad since you understand the idea of nodal analysis, and will be followed by the main steps in writing nodal equations. So before we start, what we actually should do. The first step is to assign the direction of all currents in all branches. So let's look into 4 ohm resistor. The current will be flowing downwards. Then the next one, 8 ohms, it is to the right. Next resistor, 2 ohms, again down. 2 ohms on the top to the right. 8 ohms on the right side, leaving 12 volts positive terminal, so it's going upwards. And the last current is 4 ohm resistor, it is to the left. So the most the currents, it's obvious, so we already know their direction, but sometimes it's not very clear. So for example, the direction of the current between node V1 and V2 is probably not 100% sure. So what you can do, you can pretty much guess the direction of the current, but when you start writing equation, you have to follow by this chosen direction. So you can't say that the current flows from V1 to V2 for first node and then it goes the opposite direction to the second node. This is kind of important thing. So once you assign the direction of the current, because we'll be writing we'll be using the node currents and expressing it through the voltages, it's probably useful to put the polarities across each resistor. So what's the polarities? Basically, it's just plus and minus high and low potential. And because the current flows from high to low potential, so you put just plus and minus across each resistor, followed by the current direction. Then again, plus and minus, plus, minus, plus, minus, and the last one is plus and minus. So basically we are ready to start writing the equations. And we'll start with node 1, V1. So let's see what would be the equation for node 1. We'll start with 5 amp current source, because the 5 amp, it's already the current. So we have the first current ready, and this current is coming into the node, so let's make the currents coming into the node as positive again, and the currents leaving the node as negative. So it is positive coming into the node, so we can say plus 5. Then the next current will be 3 amp. But if you look on node V1, it's actually not just the single point, it's like the whole area indicated. So the current 3 amp is going out from the node, so that's why we put minus, and that will be minus 3. The next current is 4 amps. The current is going down, so from the node again it's going to be a minus. And let's write the value of the current. What is the current? The current is expressed via voltages, Ohm's law, so voltage over resistance. But talking about voltage, again, we're taking the voltage at high potential minus voltage at low potential divided by resistance. So voltage at high potential, voltage at plus is V1, minus voltage at minus is 0, so we can ignore it, over 4 over resistance. The next current is the current through 8 ohms resistor, and again you do voltage at plus as V1 minus voltage at minus V2 over 8. We also have the current as 2 ohms, and followed by the same idea. You need to put voltage at plus, and now it is V1. The arrow actually pointing that it is V1. Voltage at minus will be V3 now, over 2. So now it looks like we completed the equation, but just double check that we included all currents, so we didn't miss anything. So let's just count the number of branches connected to the same node, to node 1. So it is 1, 2, 3, 4, and 5. So we have 5 branches. That means we should produce 5 components in the same equation. So let's double check if it is 5. So 5 is the 1, 2, 3, 4, and 5. So that means that we didn't miss any current, so we didn't put an extra. So the equation is complete, and we can say that it is equal to 0. So this is how to write the first nodal equation, and now we'll move to the second one. So now let's see what would be the equation for node V2. So start writing node 2 and what currents actually come into the node. The first current is through 8 ohm resistor. It's coming to the node, so it is positive. So let's start writing the value of this current. Again, voltage at plus is V1 minus voltage at minus is V2 over 8. The second current coming to the node is through 4 ohm resistor. Because it's coming in, it is positive, and that will be voltage at plus V3 minus voltage at minus V2 over 4. The current through 2 ohm resistor going out, so it is negative, and that will be V2 minus 2. And again, let's check if we included all the currents. The number of branches is 1, 2, and 3, and the number of components in the equation 1, 2, and 3. So that means we have 3 branches at node 2, and we have 3 components in our equation. So that means it's all complete, and the equation is equal to 0. Now we have one node left. This is node V3. And again, for V3, this is not just the point, this is the area, which is considered as the same node. So start writing the equation. So at node 3, what do we have? We do have current 3 amps, which is coming in, but before, let's do the current through 8 ohm resistor. So what do we have? The current in 8 ohm resistor, again, we have voltage at plus is 12 minus voltage at minus as V3 over 8. Then 3 ohm resistor, again, it is coming in, so it is positive. You put plus 3. The next resistor is 2 ohms on the top, followed by the same idea. It is incoming current, so it is plus. And what it's going to be? Voltage at plus is V1 minus voltage at minus V3 over 2. And there is one current left. This is the current through 4 ohm resistor. It's going out from the node, so that's why you put minus. And what would be the current? Voltage at plus is V3 minus voltage at minus is V2 over 4. And to be sure that everything is completed, again, how many branches do we have? Let's count at node 3. It is 1, 2, 3, and 4. And how many components in the equation? It is 1, 2, 3, and 4. So again, we finish the equation, and we can say that it is equal to 0. So basically, this is the idea how to write nodal equations. Once you completed your equations, you can simplify it and solve it in order to find nodal voltages V1, V2, and V3. And later, if required, you can find the current in each branch of the circuit.